Hello guys, in this video we are going to discuss the solution of the problem minimum number of deletion and insertion. So let us look at the problem statement. The problem statement says given two strings str1 and str2, the task is to remove or insert the minimum number of characters from /in str1 so as to transform it into str2. It could be possible that this same character needs to be removed / deleted from one point of str1 and inserted to the another point. So for instance, if the str1 which is given to us is heap and str2 is PEA, then in order for str1 to become equals to str2, we need to remove two elements and we need to insert one element. So in total, the number of operations we are going to do is 3, and that is what we are returning over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So to discuss the solution of this problem, let us take an example. So let us say the string which is given to us is heap and PEA. Now the general idea behind solving this problem is we are going to compute LCS. So as we can see, the longest common subsequence between str1 and str2 is of length 2. And once we have LCS, we need to find out how many characters needs to be deleted, so num deleted, and how many characters needs to be inserted. So these are the two things which we need to find out. Now, as you can see, str1 has to become equals to str2, and in this case, length of str1 is greater than str2. Then that simply means the number of characters that need to be deleted will be given by len of str1 minus LCS, and the number of characters that needs to be inserted will be given by len of string 2 minus LCS. Please note this will be the case when len of string 1 is greater than or equals to len of string 2. In the case where length of string 2 is greater, then in such case deleted will be given by len of string 2 minus LCS, and num inserted will be given by len of string 1 minus LCS. And towards the end, all we have to do is we need to return num deleted plus num inserted, and this will give our answer. So that's the general idea behind solving this problem, folks. Now the important part over here is how do we compute LCS optimally. So let us look into that. So in order to compute LCS optimally, we need a DP table. So let's create a DP table of size m by n. So let us say this is the DP table. In this case, as you can see, this is my str1 and this is my str2. The LCS between an empty string, and this is our empty string. The LCS between an empty string and any other string will be 0. So let us mark it as 0. Now let us see how we will be able to compute LCS. So what we are going to do is we are going to take ith character of string 1. So let's say this is my ith character, and jth character of string 2. And we are going to compute the LCS between str1 0 to ith character, comma str2 0 to jth character. So in between these two, we are going to compute the LCS. Now the way we will be able to compute LCS is we are going to check if the ith character equals to jth character. If ith and jth character are equal, then dp of I comma j will be given by, since one character matches because of which 1, now all we have to do is we need to compute the LCS between I minus 1th character, comma j minus 1th character, and this is how DP table will be populated. Similarly, if let's say the strings are not equal, or the characters ith character is not equals to jth character, then in such case dp of I comma j will be given by maximum of dp of I minus 1 comma j or dp of I comma j minus 1. So let me explain this. So let us say these are two string and this is my ith character and this is our jth character. And here str1 I is not equals to str2 j. The character does not matches. Now what we are saying is the LCS will be given by taking these characters from string 1 and these characters from string 2, and the solution will be stored in dp of I comma j minus 1. Please note this is j minus 1, or the solution can be found by taking all the characters from string 2, so then this will be j, and I minus 1 characters from string 1, which is this character, and the solution will be stored in dp of I minus 1 comma j. And in this way we will be able to populate our dp table. So let us apply this logic in order to populate our dp table. So in this case p and h does not matches, so we just have to see of these two which is the maximum, and the maximum will go over here, so this will be 0. Again p and e does not matches, so of these two what is the maximum will come over here, and similarly for the rest of the cases. And as we can see for the last case p and p matches, so this will be equals to 1 plus the LCS of remaining characters, and the LCS of remaining characters is diagonally available, so this will be 1 plus 0 and then this becomes equals to 1. Now let's repeat the same process again and populate our dp table. So e and h does not matches, so 0. E and e matches, so this will be equals to 1 plus the diagonal value, so 0. 1 plus 0 is 1. E and a does not matches, so here again the maximum between these two is 1, so we are going to mark it as 1. E and p does not matches, the maximum between these two is 1, so 1. A and h does not matches, so the maximum between these two is 0, so 0. A and e does not matches, so the maximum between these two is 1. A and a matches, so this will be equals to 1 plus the diagonal value 1, so this will be equals to 2. And then a and p does not matches, so the maximum between these two which is 2. And in this way if you see we have computed our LCS and the value of LCS is 2. Now let us apply this logic in order to compute num deleted and num inserted. So in this case as we can see str2 is greater than str1, so we are going to use this logic. So in this case num deleted will be equals to len of string 2, which is 4 minus LCS, which is equals to 2, and num inserted is 3, len of string 1 is 3 minus 2, which is equals to 1, and our answer will be 2 plus 1. 2 plus 1, and that is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find out min, inserted and removed, and str1 and str2 is given to us. So the first thing which we are going to do is we are going to store len of string 1 in a variable and length of string 2 in a variable, and then we are going to compute the LCS between str1 and str2. Once we have computed LCS, we are going to check if m is greater than or equals to n. If m is greater than or equals to n, then num deleted will be equals to m minus LCS, and num inserted will be equals to n minus LCS. Otherwise, num deleted will be equals to n minus LCS, and num inserted will be equals to m minus LCS. And towards the end, all we have to do is return num deleted plus num inserted. Now let us look at the pseudocode of LCS. So let us say we want to compute LCS. String 1, string 2 and their length are given to us. So the first thing which we need is a DP table of size m plus 1 and n plus 1, and the initial value of this DP table is 0. And then we are going to iterate on I in range of 1 to m plus 1 and j in range 1 to n plus 1 if str1 I minus 1 equals to str2 j minus 1. Then in such case dp of I comma j will be given by 1 plus dp of I minus 1 comma j minus 1. Otherwise dp of I comma j will be given by max of dp of I minus 1 comma j or dp of I comma j minus 1. So the maximum between these two. And then towards the end, all we have to do is we need to return dp of m comma n. And in this way, we will be able to compute LCS. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So first, we have computed the LCS. And then we are checking if m is greater than or equals to n. If m is greater than or equals to n, then num deleted will be given by m minus LCS and num inserted will be given by n minus LCS. Otherwise, num deleted will be given by n minus LCS and num inserted will be given by m minus LCS. And towards the end, all we have to do is we need to add num deleted and num inserted. Now let us look at the LCS function as well. So for LCS, we need a DP table of size m plus 1 and n plus 1. Then we are iterating on I and j. If ith character of string 1 matches with jth character of string 2, then dp of I comma j equals to 1 plus dp of I minus 1 comma j minus 1. Otherwise, dp of I comma j is maximum of dp of I minus 1 comma j or dp of I comma j minus 1. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at our C++ solution. So the C++ solution is also the same, folks. We are computing LCS between the two strings and then we are checking if m is greater than or equals to n. If m is greater than or equals to n, then num removed and num inserted will be computed as the way we have discussed. And then towards the end, we are returning num removed plus num inserted. Now let us look at the LCS function. For LCS function, we need a DP table of dimension m plus 1 and n plus 1. And then we are iterating on I and j. If ith character is equals to jth character, then dp of I comma j will be given by 1 plus dp of I minus 1 comma j minus 1. Otherwise, the maximum between I comma j minus 1 and I minus 1 comma j is our entry for dp of I comma j. And towards the end, we are returning dp of m comma n. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.